Large data bankers, welcome back from the break. Happy New Year. Happy American coup. Happy Friday. Happy I got a blue light for my shelf. Pretty sweet. I'm pretty proud of it. Feeling like this room is turning more and more into like an RGB dungeon. I'm trying not to get too crazy with it, but it's been kind of fun. What else? What other things can we be happy about? I guess well, we made it to 2021 and people are mostly still alive, I think, hopefully. I would say that I'm ready for the new year. So far, the new year has brought a couple of weird things. Hopefully those things will kind of trend down. Things will come back to normal a little bit, but we'll just have to see. I'm going to, next week, for one thing, I'm gonna go skiing. I'm actually pretty pumped about it. I haven't been skiing in a long time. I didn't go last year. It was a big mistake because obviously COVID happened and you can't go skiing during COVID. So I'm going cross-country skiing next week. It's gonna be super fun. If you guys haven't done cross-country skiing, think about it, is what I'll say. It's kind of like, people are always freaked out about cross-country skiing because it's like big heavy skis, right? Like you're used to the downhill skis and you're like, how could I even go? It's so exhausting to go straight. But let me tell you about cross-country skis. The thing that you have to know is actually that the skis are different. And like your feet, like let's say this is your toe over here, your heel comes up on the cross-country ski. So it's not like you're locked in and like, you know, the skis are just sort of attached to your boots. You know what I mean? It's kind of like, you can lift up and you can kind of walk and you sort of walk and you can glide a little bit. It's like walking, except it's assisted walking. So cross-country skiing is where it's at. I'm going to go for next week. I'm looking forward to it. That's kind of what's on my mind right now. But you guys, welcome back to the stream. Kina42, hello. Pratik, hello. Safe, hello. 1:30 a.m. on a Saturday. Oh my gosh, you're staying up late, but that's exciting. Thank you for doing that. Let's hope it gets normal. Was thinking coming back to the US is getting more. Well, is it though? I think you should come back. Safe, you'll be fine. Presumably. In the old days, cross-country skis had beaver skin, so they would only glide in one direction. Yeah, exactly. That's true. I guess like right now it's like done synthetically, I think. Like the material on the bottom of the ski is sort of, I don't know. I assume it has some sort of like friction situation set up so that it's easier to glide in one direction than another. Or you can like wax them or something like that. I don't know. I never got that into it. But I know that the like really hardcore backcountry, cross-country ski folks, they'll put like different waxes on their skis depending on the temperature. Although they probably do that for downhill, don't they? Maybe waxing is just sort of like a universal thing. I don't know. Anyway, hi Lisa. And yes, welcome everybody. So yeah, today, man, Becca was asking how often you get folks in your audience making technical suggestions on chat. I would say probably, well, it happens a little bit most streams, I want to say, but I feel like I also have an advantage because often I like nerd snipe some people that I either currently or used to work with, and they kind of have a better idea of how to give suggestions. But that being said, I feel like I've gotten plenty of suggestions from random Go folk in the audience because I'm not a Go expert, right? I'm just, well, yeah, I don't know. What is an expert anyway? But like, I think that people are good at Go in ways that other people are not good at Go, right? Everybody has reasonable suggestions. I'm always interested in hearing style points from the audience, right? I want to hear your suggestions, testing tricks, you know, everything. So I guess like, I would say with some frequency, and I'm always open to it. So I don't know if that answers your question, but it wants to be interactive. The stream wants to be interactive. I want to take your suggestions. So what are we going to do today? I think we're going to start off by playing with user-defined function stuff. We started working on it over the break. We got some pretty good progress on it, right? I got some really good reviews, for example, from one colleague here in the audience. Kina42 has spent a good amount of time giving me some excellent feedback on that PR. So I had some work cut out for me, I guess is what I'll say about that. And I think what I was going to try to do today is probably look a little bit about how we store overloads for user-defined functions. So Well, what I think I'm going to do is probably start talking about that a little bit more, because what is that even about? I don't know. Well, let's try to find out together what that means, maybe. So I'm going to jump over here into the desktop zone. And let's just go ahead and get our minds back into this project a little bit, so that we can remember what we're up to. Actually, let me quickly open up my stream labels too, so that that's all good and go. Put this over here. Okay. Stream labels, important thing to open before your stream. So what is this all about? Let's go ahead and just kind of remind ourselves here. Maybe I will start by running, just like building this branch on my remote machine, because I haven't done that in a little while. And yeah, I think last time I didn't remember to do this, but just while I'm streaming, it tends to be really inefficient to try to build the database on the same machine that's doing the stream. Things get slow, things get kind of sad. So I like to have a VM in the cloud doing kind of these builds and stuff like that while the stream is going. But yeah, I think, you know, what we could do actually is maybe investigate what we are in a sense supposed to do, right? Because CockroachDB, we all know it, it's kind of trying to be Postgres compatible in many ways. And so a really good way, if you're trying to build a new feature for something that kind of already exists in other databases, is to check out what Postgres does. Postgres, great database, really nailed all the ergonomics. So let me make a user-defined function here of the same sort that we're aiming to support. What is it all about, right? It's going to be create function. Maybe we can call it add numbers. We specify the input parameters. We specify the return parameter, returns int as, and we're going to say select a plus b, language SQL. Yeah. So this is going to do a good thing, right? And specifically the thing about overloads that I wanted to try to address is that in Postgres, you can give another function of the same name. You can make another function of the same name. It's kind of weird, with different parameters, right? I couldn't do this. This is exactly the same thing as the first function I made, because it's got the same argument types. But I could make another one with another parameter, right? Like this. And that would work fine. And that's kind of weird, because if you're just thinking about doing name resolution for these functions by looking up the name of the function, it's not going to work. Like, there's more information that you have to do to figure out what's the actual like text or whatever. What's the actual implementation of the function. So that's kind of the challenge. And our initial implementation in Cockroach, it actually sort of ignored that. So it sort of permitted a single overload. And I think, let me see if I can just demonstrate that over here on my remote machine. If I said create database, or I think we already have this one, use default DB, create function, add numbers. I'll do the same thing here, a int, b int as, or returns int as select a plus b language SQL. And then I said, let's just check to see if this works. Don't remember exactly what the state of this branch is. Okay, so that seems to work. But if I said then create function add numbers a int, b int, c int, like we did in Postgres, it's going to say function add numbers already exists. So that is going to be trouble. And the reason for this is that the way that we've implemented things in this namespace table, we in CockroachDB, we use a special system table called the namespace table to resolve names of everything, including tables, views, user-defined functions, user-defined types, schemas. So I'll give you a peek into that actually, just since we're talking about it. I can say select star from system.namespace. So what this thing has is actually, you know what's going to help is actually if I show you how this thing looks on the inside, like show create table. Like what is it? What are the keys of the system.namespace table? It's pretty important. Whoops. The answer is that it's got a primary key. If if you're used to your SQL, right? That's what we're doing on the stream is we're building SQL, but how many of you actually use SQL? So here is a primary key. It points from parent ID, comma, parent schema ID, comma, name to ID. And what this tells you is that you can use this thing to look up given a parent database ID. I guess it doesn't say that, but I happen to know that this means database ID. Given a parent database ID and given a parent schema ID and given a name, you can look up the sort of ID of the object. And so what we've kind of done here is we've stuck our add numbers function using a weird prefix that I think we talked about a little bit last stream, but ignoring that for a second, we've sort of stuck our namespace entry here without using any of the type information. So there's no sort of ability to add overloads in the way that we've organized things so far. It's kind of like, is there something called add numbers? Yes or no? If so, it's already there. Can't do anything good. Don't forget that Postgres has type aliases, small int, int4, overload resolutions after the types are normalized, not on input syntax. That is a good point. So Raphael is pointing out that if I were to go over here, so integers, right? There's a few different varieties of integers in Postgres of different widths, right? And I think int by default is an int4. And I think what he's saying is that if I were to say create function add numbers a int b int 4, it's going to complain that such a thing already exists because int and int 4 are sort of just the same thing. But if I were to say b a int int or a int b int 2, I think that this would presumably work. It actually doesn't though. How about that? So that's kind of interesting. Oh wait, this is in Postgres. That's the problem, or in Cockroach. So of course that wasn't gonna work ever. But in Postgres, if I were going to try to do this int4 thing, this is the same thing because int and int4 are the same, but if I said a int b int 2, presumably this will work. Okay, it does in fact work, meaning that we've now defined an overload that will only get called when we have an int4 on the left, an int2 on the right, and an ordinary, or I guess an int4 on the return type. So that's kind of fun. We have to figure out how to represent that thing basically. Did also mention elsewhere that you want structural dependencies on type IDs, not names. UDFs follow type renames. Yes, that is an excellent point. And so what that is about is essentially saying that we need to make sure that instead of storing the OID of the integer type, in other words, okay, so back in Postgres land, what I can say is I can get the like special internal ID of a type by saying this, select int, and then I cast it to reg type, which is this kind of weird syntax thing that lets you get from name to internal ID. But by doing this, I can get that the sort of internal ID of an integer is this 23 thing. If I ask for the internal ID of an int2, I get 21, and et cetera, et cetera. If I were to make a new type, create type my enum as enum a b, and then I were to say select my enum reg type OID, this is going to have some big number indicating that this is some user defined thing that kind of showed up later. Anyway, the point though is that like I need to make sure that whatever I do to store the sort of new name resolution stuff, right? We've got to fix this problem here, which is that we don't include argument types or return types in this sort of lookup machine. Whatever I do, I need to make sure that what's included here is actually this number in a sense and not the name, since if it were just the name, we wouldn't be able to sort of notice when things change, or rather we would have to go and edit everything when we change the name of something, which would really be problematic. If we just include some ID and we don't include the name, then if we change the name but keep the ID, we don't have to sort of go around modifying stuff willy-nilly, which would be kind of a pain in the butt. I do think that regardless, there is a little bit of a pain in the butt syndrome here, just because I think it's pretty new to us to have a concept of an entry in this namespace table that contains a dependency on some other thing. That's like a pretty weird concept. Most of the time, if you imagine like a table that has a dependency on a user-defined type, we normally don't store that information in this namespace table, which is normally just for doing lookups of names. We store it in this other table that contains the descriptors, right? We've talked about these descriptors before on stream quite a bit, but I'll just show you kind of what that looks like so we can all remind ourselves. Where am I at? Font. Okay. So if I were going to go to the structure.proto thing, which is sort of where we store the, how's Go working out for us? Still happy with it? Yeah, I think for the most part, I would say that Go is a great choice for a programming language for Cockroach. I think there's some problems with it that we've talked about a little bit on the stream, especially with regards to memory management. Since you are, as a database, you really want that fine-grained control of the memory that you are using, and Go doesn't make it that easy. So I'd say the biggest problems that we have with Go are probably memory management and like CPU accounting. In a sense, there's no real way to do some of that low-level stuff, but we're finding ways around it, and it's kind of like all good essentially. What's up, Lithium? And Pun, by the way, welcome to the stream, and thank you for asking the question. Trying to get Go to take mic input so I can make my own proximity chat for Among Us. That sounds like a pretty fun project. Generics versus exec-gen. That is another good point. Yeah, I think the exec-gen stuff, I don't know. I mean, I guess I have some regrets, but like, you're always going to want some kind of, presumably most of the time you want some level of customizability that isn't going to be built into your language. You're going to run into problems no matter what language you choose. And like, what are the alternatives, right? That's kind of the main thing. The alternatives are kind of like Rust. Everybody wants you to talk about Rust. And I still wouldn't choose Rust for Cockroach. I just don't think I would do it. Good parts and ugly parts. The time wasn't Rust. Yeah, I just still don't think I would choose Rust. .NET and the problems are pretty similar. Garbage collection is a blessing and a curse. Yeah, absolutely. Right. So what I wanted to quickly say about this protobuf stuff, though, is that like most of the time, if you look inside of this table descriptor business, is just sort of where we like store the, guts of a table. How does the table look on the inside? This is normally where we have these references that we have to keep track of. Like, for example, wait a minute, I guess it would be in column descriptor. This thing is sort of a child of table descriptor, but this reference here, SQL sem types type, this guy is going to have like an entry that is right. So in our example with custom types, if we had a table with this custom type, it would look like all of a sudden that this thing contains an ID that isn't sort of containing a built-in CockroachDB type. And it means that if you drop the type, what do? You have to know that this table references the type. So I think most of the time, though, like these references live in these descriptors and not in the namespace table. So I just feel a little bit funky about it. But that being said, I don't know. Maybe it should be fine. So anyway, I was thinking about how to do with this with Raphael, Kina42. And we were thinking that probably what we could try is just kind of sticking the IDs of the argument types and the return type, which are sort of the two components that together make a unique key along with the name of the user-defined function, into the name field here. And the only trouble is that we have to figure out a little bit how to escape some of this stuff, because let's say, for example, that you chose the character. You have to choose sort of like a separator character here, right? You have to say like add numbers and then a separator and then the ID of the, types or whatever, and then a separator, ID of the type, separator. And if you choose something, if you just like randomly choose a character, it's going to have problems, because if somebody makes a function that includes that character, that thing like will be invalid and like screw up all of your encoding essentially. So what you have to do is either, pick something that's reserved and use that as your separator, or you can kind of define a sort of an escaping scheme where you pick some character and you use that as your separator. Then if a user like puts that character into their user defined name, then you escape it using some other sequence. So there's some choices. The return type is not part of the signature. It isn't? MD Layer. MD Layer is our surprise special guest. He's de-surprised himself, but he'll be back. We're going to have a conversation on stream in a couple of hours. It's going to be good. Coffee time. The return type is not part of the signature. Is that really true? Is that actually true though? Is that actually true? Create type, create function, add numbers a and b and returns and as, okay? So here's our thing, this already exists. And you're saying that if I said returns int 2, you're saying that this is gonna work. You're saying this is not gonna work. Indeed, it appears not to work. Oh, well, that actually makes things a little bit easier, huh? My wife doesn't let me out with 3 kids. GopherCon. Beer with MD Laird. That does sound like a fun thing. Can't have 2 different UDFs in Postgres that only different return type. Otherwise, resolution can't work. But presumably, I mean, maybe they use a type resolution algorithm that doesn't like really allow for that. But you could imagine that you could put functions in different contexts, right? And then if it detected that the function was in a context that needed type A, then it would use function A. And if it was in a context that needed type B, then it would use function B. But maybe the Postgres type resolution just doesn't really work like that. It's like in principle, I think this should be possible. It doesn't drive resolution by demanded type. I see. The cockroach DB special. The more I look at compatibility, the more I think that like, man, the more things that we have like that are the cockroach DB sort of special thing, it's not necessarily good. It is not necessarily good. So let's go ahead and take a look at our create function and see what is up here. See what is up here. Type system needs to be replaced. Could be so. So here is what we do today to create this quote unquote mangled name. This is what we call the mangled name, to make sure that we don't have, that we have a separate namespace for functions than we do for tables, which is another really irritating concern that we had to deal with for this particular project, right? Like you can have a function called add numbers and a table called add numbers, and those things don't conflict. Pretty confusing. So this is what this mangled name is about. And right now the name mangling, all it does is it adds this prefix. It adds this .fn thing up front. Then it puts the object name. And I guess like the basic idea here is that what we want to do is to, I left out a very important part of this whole equation, which is that during function name resolution, right? During function name resolution, we need to actually have on hand all of the overloads for a particular function in order to choose which overload to use, which means that if we went with this scheme that I've been talking about where we sort of append the argument types to this namespace name, then you have to do a range scan. So to collect all of the things that start with add numbers, and then you can like choose which one you want to use. That's one option. The other option is that you could conceivably have like, you know, one master descriptor for a particular function and then like one child descriptor per overload. But I don't really want to do that because it just like seems irritating to have to, like, imagine you're deleting the final overload from a function, then only at that point do you have to delete the parent. I don't really like that. Like, to me it feels a lot simpler to have a prefix and just like a single descriptor per overload. That way you can do this sort of simple one-to-one mapping of OIDs to overloads, which we sort of want to do for compatibility reasons as well. So what that's about is like, you know how I was trying to convert these things into these reg type internal IDs. Well, it turns out you can do exactly the same thing for user defined functions. So you can say select add numbers and then cast this thing to regproc and then cast this thing to ID. More than one function named add numbers. Okay, so maybe it doesn't work in the case where there's like multiple overloads. What's up, JB Pratt? Welcome to the stream. Nice to see you. Great function. Foo a int returns int as select a language SQL. Kadobes. Hey, Kadobes. Oh, drop function foo. Oh my God. Okay, I've been playing in this database for too long. I've like littered it with random crap testing stuff. So I've made a function called bar, and then if I turn the bar into an internal type, then I get this thing here. And this is the internal type. And the point is that every single overload has its own special ID, which kind of means that we really want like one descriptor, one ID, one reserved thing per overload, which is sort of how this whole mess began. Like originally I was sort of hoping that we could say like, there is a single descriptor for all of the overloads in a function, and you just keep editing it. The issue with that is that you don't reserve these special numbers, and it's quite important to do that. So anyway, on and on and on. Slightly blah, I would say. I would say that, you know, conceivably you could also just decide to keep that as your method, but then like reserve an ID every time you make an overload or something like that. But I think that has major problems, because like imagine making the first overload, then make the second overload, then you delete the first overload. Like what do you do with the first descriptor? So that's a mess too. And I think that, to be honest, the easiest thing is just have a single overload per descriptor and use this range scanning thing to get all the descriptors for a particular name. So that's what we're going to try to do. And I guess what we've got to do at this point then is figure out how we're going to make this mangled name, right? That's a kind of like the step number one, is to come up with this encoding. So we kind of have to think, okay, we've got our types here. We've got our types over here. And I think the first step is basically to say like, maybe we give mangled name an argument, a set of arguments, which is like the types basically, right?
The data bank's too big.
Cloud Cappuccino, thank you for the follow. Thank you for the follow. What if we just pass in these types to mangled name? So this thing is going to take a list of types.t. So it's going to be param types. Am I allowed to import types from the tree package? Is that a thing, or is that backwards? RG types package SQL sem tree. Okay, that seems fine. That seems fine. Okay, so then the question is, right, how do we encode this thing? I mean, like the simplest thing would basically be, the simplest thing that's totally wrong would be that we would want to say, add for every type. Let's see. So we're gonna make a string buffer maybe. String builder. What is that thing called? Strings.builder. Var buff strings.builder. We're gonna say buff.write string func prefix. So we're sort of building this thing, right? The end goal is to have a name that includes both the function's name and its argument types. Argument type IDs, I should say. Argument type IDs. So it would be something like, you know, in our example of add numbers, right? It would be like add numbers, and then it would be, you know, the ID for int2, which I guess is select int2 reg type OID 21. So it'd be like add numbers 21, 21, something like that. So it's just like, as a dumb example, knowing that this isn't really going to make that much sense, we'll just get the skeleton here. We're going to write our string of t.object name. Then we're going to say for I in range param types, we're going to say buff.write string. And we'll say like strcon.a to I guess it's I to A. I to A. Param types of I dot ID, OID. This is a uint32. Okay, so I can just intify this thing. Okay, so this would give us something that looks like literally like this, which is fully wrong, because then you could imagine somebody goes around and says, you know, create function add numbers 21, 21, and then that's gonna like kind of conflict with what we've got here. What is wrong with this? This is a name, so we have to stringify it. So basically, I think what we want to do here is introduce a special couple of things. We need to make like an escape character. We need to make a separator character. And then we need to make sure that any separators in object names are escaped, and any escaped characters in objects are also escaped. And then we can have a special escape encoding for this stuff, and like we should be all good. Yo, Brohanster, welcome to the stream. What is up? We are working more on user-defined functions, getting those overload support. Overload support, a truly important but annoying thing. So, okay, how about we choose the same dot thing that we used up here, just because like it's sort of fun. Does it matter? I don't think it really matters. So we can say const. Is this thing like a weird UTF-8 character though? It probably is. So we probably don't actually want to use that, right? Because that's gonna just be like deeply confusing. We probably just want to use like some random character. Like, what should we use, guys? It should be a single byte. What if we just use slash? How close is the UDF-PR to landing? It's not close. It's not close. This is an important consideration to resolve before it can be landed in any way, shape, or form. Just because it's like getting the encoding right is sort of permanent. If we mess that up, it's gonna be terrible. 70%? That's high, but maybe you're being generous. I don't know. So let's say our sep is this and our escape is this. How about that? Is that horrible? Should I like get real with myself and not be so goofy? Okay, well, let's just, why is this not unused? I guess it's not that important. So ultimately what we want to do here is we want to say buff.writeString, right? I guess we can say write byte, sep. And then over here in object name, this is kind of the trick, right? We want to take our object name, obj name, and we want to escape any escapes or separators in obj name. So we want to say like, isn't there like a strings.replace kind of thing? All right, so I guess the first thing is that we want to replace any escapes with double escape. Right? Is this valid? I think it's valid. We want to replace any escapes with, I guess these should be strings. So we want to replace any escapes. Wait. Obj name, place any, and we have to do this in the right order, right? If we did separators first, then you're going to end up with escape characters, and when you try to replace those, you're going to like double escape your escape seps, which seems wrong. So I think what you want to do is first escape your escapes and then escape your seps. So first escape your escapes, replace escape with escaped-esque, and then you want to replace your obj name is equal to strings.replace obj name sep, and then replace this with escaped sep. Then we write our object name. Then we write our separators, and then I think we're good. Maybe
Computers hooked into over 1,000 data banks throughout the world.
it would be good to meet some of the faces in Go. Yeah, I agree. That would be really fun. I think that the Go community is great. I think that the Go community is the first programming language community that I actually feel like I sort of understand it. I sort of like am interested in, you know, interacting with it. And to be honest, like, yeah, man, I'm excited for GopherCon to come back, be IRL, meet some people. I think before Go, I don't know, like I'd done Java stuff. I guess I went to some Perl conferences when I was a kid, actually, because like I was really into Perl as a youngin for some reason, and some people like dragged me to a Perl conference and I met people, but I was like too young and I didn't really know anything about conferences, and it was really awkward. Like I don't know, that was really weird. But theoretically, like that was a chance to understand a programming language like conference community. It's just it was sort of the wrong time for me. Sappy tweet about how I miss seeing the people in the community. Go 1.0. Dominic is like an old school Go person. We're all very jealous. Using Go pre-beta. Wow. Man, you guys are all old school Go people. I'm a late school, a boomer gopher. Yeah, you guys are all gopher boomers. Unbelievable. Just use it for personal things. Yeah, I guess. Hold on a minute. Wait, didn't I do something like this? I had a project called Gomps. Didn't I have something? What? So 11 years ago. What version was Go in 2009? 2009. That's pretty old, right? Am I legit? I had to use a .6. I think this is pretty old. 6G? Like, this is old school. 1.0 is 2012? Okay, I'm OG too, you guys. I'm totally OG. This program basically was it tried to be a simulator for MIPS, I think. It was for like this computer architecture class that I took in college. It was pretty sick, I think, maybe. I guess it might have like read assembly. I have like no idea what this said. I didn't leave any comments, dude. I didn't leave any comments. Like, this thing is just basically random dead crap that nobody will ever understand ever again. Look, like, are you kidding me? What is this? Why did I do this?
Everybody knows that relational databases don't scale because they use joins, and right.
Matt, thank you for the 1 month of gift sub to Demeet. I really appreciate that, my friend. And Demeet, welcome to the stream. You are now a large data banker. Does it even run? I think this thing does run. Okay, so the main end point of this program, you guys, it was actually pretty cool, was that it could run this program. Look at this. Jordan. Look, I was in school once. Jordan Lewis, matrix multiplication assignment. And I don't remember what this was for, but essentially this is an assembly program for MIPS that does matrix multiplication. And I guess I wrote this program and then also wrote the simulator for the computer that can run this thing, maybe. I think that's what happened here. Anyway, great stuff. Technically, Go still has semicolons, but Go format gets rid of them and compiler reinserts them somewhere. That is interesting. Yeah, we've come a long way. We've gotten rid of those sixes. That whatever that stuff is from. Plan 9. Plan 9 influences in Go are like, I guess the ASM is still like Plan 9, right? Installing Acme. I had a colleague, this guy Matt Gibson, who still uses Acme. I mean, like, all of his stuff is Acme'd up. I think it's pretty good stuff. So people still use that stuff, I think. Okay, so does this make sense, you guys? We write our separator, we write our buff, and then we return our buff.string. And then we've got this thing that's theoretically mangleable, right? So like, let's take a look at some examples. We should write a function, a test for this for sure, but let's take a look at some examples. So for add numbers, you know, why are we even A2I-ing this stuff, right? Like, or I2A-ing this stuff? Shouldn't we just write it as a byte or something? Yeah, maybe I2A is actually fine. I don't know. Who has thoughts about I2A-ing these things or not? I feel like it's going to be nice to be able to at least like read it in this, maybe. I don't know. So it's going to look like this, right? Add numbers /21/21. And then let's say we had a function that somebody tried to be sneaky with, right? And they call it add numbers slash. Put some escapes in here, right? Maybe some escapes. Maybe just all sorts of crap. I'll make a test for this case, I guess. No idea how this works on Mac, but it appears I'm gonna have to start Zoom on Linux, then OBS if I want my webcam and stuff to work. Yeah, there's definitely some issues with like the webcam working on 2 spots at once. I did test this before the stream. Basically what I'll do is disable the webcam on OBS and only enable it on like Zoom or Hangouts or whatever we're gonna use. So I don't know, we'll figure it out. There's enough like techie people on the stream that if we can't, they'll probably help us anyway. So the first thing to do is that we replace the escapes with the escaped escapes, right? So our escape in this case is the backslash. So we're gonna replace this, we'll replace this, we'll replace this. Then we're gonna replace our separator with escape separators. So our separators turn into this. Right? And then we don't have these quotes in our actual output, so then we'll do an actual separator, then a 21, then a 21. So then I think theoretically what we do to do the range scan is that we say we just mangled the name up to the separator, and then we do a range scan there, essentially. No, including the first separator, right? So that's going to give us all of the things, excluding things that have it as a prefix, along with all the outputs. Ooh, you know what's I think important is that if we have a function with no arguments, I think we need to include the prefix, right? Which means that our algorithm actually has to look like this, I think. Can you make a function with no arguments? Let's see. Create function f returns int as select 3 language SQL select f. Okay, yeah, that works. So we do actually have to include this special separator at the end of things always, and I guess to avoid writing this on the last one, I guess, I don't know if it's important. Just for cleanliness, we might as well not do it, right? So we'll say if I is less than param types -1, I guess. Right? Then do we have to parse this thing? Is this terrible or what? I don't think we ever have to parse these, right? We just have to compare them, which is sort of nice, TBH. I don't think we have to parse these things ever. Okay, so let's like write some tests for this thing, right? Trying to get stuff to compile with Sego. That stuff is pretty annoying, I want to say. How do I test for function? Okay. Okay, so we're gonna have a test case that looks, well, we probably just want this to be a tree.func name like this. So our name is gonna start out with something simple like tree.newfunc name. Is there such a thing? Is there not? New unqualified func name. New unqualified func name. Give it a name, tree.name, or it's just name of foo. Do have to do tree. We're in this test package thing. What do you guys, what's your opinion on test packages? Chat. Do you like the test package pattern or do you hate the test package pattern? You know what I'm talking about with the test package where you put the underscore test business? Yeah, package food test pattern. I guess they call it black box testing. I really want to customize this test generator thing because I feel like it's annoying. I always do the same transformation to it up front every time, and it's like not that good. Okay, so let's have a param type slice here that just includes like an integer or something. Types.int, types.bool. And then our want is going to look like foo. Now what is an int again? It's a int8. So 20 and then no. 20 and then 16. External tests. Okay, so we'll do this. We'll have a nil here. So this is gonna look like just foo. We're gonna have a thing with some escapes in it. Now let's take our same example from over here. All hail go comp diff. I feel like you told me about this at one point. Add numbers. Okay. I guess I could use this thing. Doesn't this make you not have to escape stuff? Yeah. Okay. So then our want, yeah, I don't think we need it in this particular case. Our want is gonna be this thing, right? Our param types are gonna be int and int. We'll do, so it's gonna be 20 and 20. Like this. Okay, so for each of our tests, we're gonna say actual is equal to tt dot name dot mangled name of tt dot param types. Come on now, tt dot param types. If got, we'll say if actual is not equal to tt.want. I can do this. All right. I said TT. Okay, so let's go ahead and try this out. This is package SQL time tree make test package equals package SQL sem tree test equal, what is it called? Test func name mangle name. Test func name mangle. Mang. How about that? So, okay, that's the first step, right? The next step is going to be figuring out how to do these range scans, I think, right? So the whole point of this is that because we have this way to sort of end a name in a sense, and you can give me all of the names with that particular prefix, right? And it's going to give you all the overloads. You deserialize all of them, and then you create your sort of like function overload list from the descriptors inside. And then you can do name resolution and it's all good. You have overloads, everybody's happy. So I feel like that's going to work. The only thing that I don't really know yet is what it's going to look like to add range scans into the name resolution like code paths, which feels a little bit funky. We don't have something like that already. So this is going to be param types, right? Param types. Renames are going to be fun. Renames of a user-defined type or a function. Oh yeah, function, I see, because you're gonna have to delete all of the things, all of the functions in the namespace table with a particular name and then re-add them. That does seem terrible. But I feel like it should be easy because like this, I mean, maybe not easy. Yeah, you got to index the names. You got to index the names. It is a bummer for sure. Okay, wait, desk. Why is it even doing that as a... Why is it doing this as a... Oh, it's because it's an external test, I guess, and it's importing other stuff, and I've got to make sure these things compile. I'm indexing these names because of the various unfortunate facts. I mean, to be honest, like the only reason that I'm doing this is that we need to reserve an integer OID for every new overload. That's like the core of the problem here. And we're sort of springing to doing this via the namespace table. And I think we kind of have to, because the namespace table is how we, I don't know. Living in the descriptor. Alter function rename to, it'll just be rewriting all the overload descriptors and all the names and descriptors. Yeah. OIDs are so dumb. Okay, get func by name. Aha, so this is where we have to do our special prefix scan thing. Yeah, I mean, we don't have a way to do this even a little bit. We would have to say tc.collection. Like, oh man, no wait, this is actually so bad because it means that you can never lease these things because you might always have, there might always be a new overload, which seems like a disaster. So it seems like this isn't gonna actually work and we have to do something else, right? If you do a range scan to collect all of the members of a set of overloads, you can never cache. Two-level descriptor for functions where there's a parent descriptor, right, exactly. Well, we were talking, yeah, exactly. We were talking about that earlier. And the only thing with that sucks is just that then it's like yet another space where you can have mistakes, links that don't exist anymore. And then you have an extra used ID where you'd like really rather not have an extra used ID. I don't know. I just think that this is actually really problematic because of the leasing situation. Who cares about an extra use ID? Yeah, I guess nobody. I was thinking that like doing deletion is annoying in that world too, because you can't just delete a descriptor. You have to check to see if there's any other children left, and then you get to delete the whole thing, which maybe isn't that bad. Maybe that's not that bad. I mean, to be honest, maybe what we should do... Okay, you guys, what if what we did is we stored a parent and then we stored in the descriptors table just like a stub? What if we just stored a stub so we don't have to worry about like doing any kind of crap? You just store a stub that has like nothing inside or something like that. Because I just don't really see the point of like overloads have their own owners. Oh my god. Dude, life is hard. Life is so hard. Okay, let's take. What are they even talking about, you guys? What are they talking about? What are they talking about? Let's find out. Okay, so here we are in Postgres. How do I like? Okay, df gives you all your overloads. So you're telling me that I can say grant execute on add numbers to foo. Wait, create. Okay, I this database is like way too much crap. Okay, wait. Grant function privileges Postgres. Grant execute on you have to say on function. Okay. Function name is not unique. Specify the argument list to select the function ambiguously. Okay, exactly. Well, you said it. You told me. Didn't believe you, but you were right. A integer, B integer. Wait a minute. Okay. Dude, look at this. It doesn't care what names you put. Look, it doesn't care what names you put. That's so stupid. I guess it makes sense. You could just as well say integer, comma, integer. All right. Okay, so that's what we're gonna do then. We're gonna do it. We're gonna have a 2-level descriptor thing, I guess. Imagine if you could just overload the parameter names. Yeah, that would make literally no sense. Juice Cop, what's up? Life is good. Welcome back. Does rename require disambiguate? Good question. Alter function. Add numbers, rename to add numbers to. Oh God, oh God. This is terrible. Can you check something in Postgres if you have 2 overloads? Yeah, but what about the leasing? The leasing is really a problem because it means that we can never lease these things. You always have to do a namespace lookup every time, which seems like truly bad. Can you check something in Postgres if you have 2 overloads in 2 different schemas in search path? Are they both candidate in unqualified calls? If you have 2 overloads in 2 different schemas in search path, are they both? Oh, I see what you're saying. So you're saying, okay, let's say create schema blah, create function add, create function blah dot add numbers integer 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 as returns integer as select one language SQL. Okay, so right now this won't work. Select add numbers 1 2 3 4. This is gonna say nothing. Then I say show search path. Set search path equals Jordan public blah. Is that how this works? What? Oh, did I screw up the search path thing though? I screwed up the search path thing. I need to figure out how this works. Is it like this? Oh my lord. The collection of overloads across search path needs to Oh no. Oh man. It's not good. We've landed in a terrible place. Tycho-ish, what is up? What is up? Welcome back. It's good to see you again. We're in a terrible place. What the heck is that? Okay, so regarding what your question was about, are you saying it's a problem because you don't know the types? No, the problem that I'm thinking of is that if you want to do name resolution, for these user-defined functions, and you don't have, if you have to do a range scan to pick up all of the possible implementations for a user-defined function, then you can't cache things at all, ever, right? Don't you always have to go back to namespace? And if you always have to go back to namespace, then like we're in bad trouble. Select add numbers. It's just sort of like these, but why are you trying to do this? Because we're trying to implement it. We're trying to add user-defined functions to Cockroach. You shouldn't want to do this. I agree that you shouldn't want to do this. This seems bad, but you know, people are gonna want a people. People are gonna want a database. That's just like kind of the thing about it. People want what people want, and you gotta give the people what they want. Right, Sam? Seems fine. You want to pass the output of one function to another part. Yeah, I don't actually understand what you guys are complaining about with this thing. This doesn't seem that bad to me. What I'm talking about is like, okay, look. Back to namespace land, right? Maybe you guys already got what I'm talking about. If you see this, right, and you have like all of a sudden like 5 of these things, and every time you want to figure out what's available, you've got to scan all 5 of them, but it's sort of arbitrary what's inside, then you can't cache them. So you can't do this approach. It's just too bad, and you have to do the parent descriptor approach. If you do the parent descriptor approach, though, that's also a big problem because you can't rename just an individual overload that way. Maybe we ought to just compromise on the renaming of an individual overload. What do you guys think about that? Like, what if we departed and said you can rename functions, but you have to rename all of the overloads at once? What about that as a concept? I feel like that would be fine. I don't know who would get mad about that. I don't know who would get mad about that. And if you really wanted to do it, you could just make a new parent. Yeah, exactly. The reason that these cross-schema overloads are important is that this is the way folk use custom schemas to overload predefined functions. So in other words, you're just basically saying that every time you have to do a name resolution that includes collecting all of the descriptors for a given user-defined function across all the schemas. Yes, I think you're right about that. I think you can't just give up at the first one. You've got to go all the way every time. Which is also terrible, because if you don't have a negative cache, then you're back again re-resolving things every time. So you're just in bad trouble, right? You're really in bad trouble here. Maybe you can, what's our philosophy with the negative caching stuff anyway? You can't short circuit because of this thing. Well, wait a minute. Can you short circuit? Yeah, I guess you can short circuit if you found a matching overload. Yeah. You do the leaves first? We're talking about a different, yeah. If you do find a match, that's okay. Right. That's actually a good point. It's like, it's only if you don't find a match. Maybe this is all fine then. Maybe this is all fine. So you know what we should do then? Hold on. Let's try to figure out what's up. Let's try to just, I think all of this stuff can go. We did some work. We figured out stuff was going on. I think we can just like basically stash this stuff. Let's make a new branch. Create func. We'll call it range scan abandoned. Do you guys like my branch naming conventions? Abandoned range scan approach for overload. Okay. So back over here then. I guess then what we want to just quickly prototype here is if we go to structure.proto, we go to our func descriptor. Basically the idea is that instead of having an overload embedded inside of this descriptor, what we really want to do is make an outer message. So we'll call it func overload descriptor, I guess. Func overload descriptor. And it's gonna have, basically we'll just take this stuff, I guess. And it needs to have privileges, and that's like, oh no, I mean, honestly, what we really want is actually to keep this, and it's, all we want is to be able to like reserve an ID. That's all we want out of all of this stuff. Like what we really want to do is say like, you know, optional reserved descriptor ID is equal to 5. It's good to want things. I agree. That's an important part of life, you know, wanting. I think it's like, isn't that like the central cause of suffering though? You know, desire is the central cause of suffering, I would say. So maybe it's actually bad to want things. How about that? Optional, this would be what, an integer. Man, let's put the descriptor on the leaf descriptors and make them, we will really want to lease the leaves. But you can just lease the parent. Lease the parent. There's no need to lease a leaf or a parent. It doesn't matter. You could just lease the entire collection of all of the... But renames? I mean, for renames, you just like pull out the one that you want to do and you create a new top level descriptor and you stick it in there. And if there's one that already exists for the same name, then you find it and edit it. I don't know. But cross references. You're talking about things that refer to user-defined functions. I am not a Buddhist. I've only heard of things like that. But I think that there's some truth to that, right? Like desire and suffering do seem to be linked. I don't think that you have to necessarily be religious to believe that. The more you want, the sadder you get when you don't have it. Or you do have it, then you want more stuff. I feel like that stuff is really real. Let's say we have functions and other functions that then get used in views. Yeah. So basically the way that would work is I have no idea how that would work. I mean, we'll eventually need to make the desire thing is Freud? That doesn't sound right. Imagine we serialized that. It's like the number of bugs per number of lines of code. Yeah, it's very similar. Imagine we serialize the view query referring to the overload by ID. Right. So, I mean, what we definitely are going to need is this like back references thing, which we use elsewhere, right? Like referenced by. Referenced. Where do we have that? Referenced by. I thought we had another one of these. Where the heck is that other thing? Depended on by. So I guess the idea would be that we would have a depended on by thing. You can rename just, if you can rename just an overload and you're not storing the body of the overload in a different descriptor from the parent, you're in trouble. I see, because you won't be able to figure out which dependencies are on which ID or something like that. I don't know. I'm not like... Yeah, maybe you're right. I don't know. Okay, well, we can just go with that for the time being and see what's up. I just don't, I mean, I do feel like it's going to be annoying that we have like too many lookups in a sense. Like it's nice that all of the information is sort of kept in this top level thing. Non-trivial use cases for user-defined functions that won't have a pathological impact. Well, I think that that's not true. So what would you define as non-trivial? I think so. The way that this thing is working right now, it's pretty neat. It's pretty neat. The idea is that it uses the optimizer to turn the user-defined function into like the same kind of thing that it's almost like a view. That you should think of a user-defined function in this implementation as a view onto a expression, as opposed to a view onto a table. And so given the fact that you have that, you can have the optimizer do all of its magic on the user-defined function, and it, in a sense, compiles it down to the same primitives that we would use in any other kind of SQL query. Dependency could be parent ID plus child ID, maybe. Yeah, I see what you guys mean. I think that that's like a reasonable thing, I guess. I don't know. Array types of enums are their own type and point back. That seems good. That is a good point. That is a good point. Tychoish, do you know what I'm talking about though? Do you understand what I'm saying with this optimizer stuff, or do you still disagree? Because I'm very curious for your thoughts actually, and your prior experience on databases. I won't out you, but you know, Tychoish did database stuff once. Okay, so all right. We're gonna try this out. We're gonna see what it's like. So we need a def, we need a param names. We're gonna need some kind of privilege descriptor business, which like, I don't know. I think for now, I'm gonna not include it, but I just wanna make a note that it will exist one day. Privilege descriptor stuff should live here once we support privileges that are relevant for func descriptors. The reason we don't really have this right now, like we just haven't added, oh my God. Wait, speaking of this, you guys, I found something really horrifying. I found something extremely horrifying that I just want to quickly show you. Okay, privilege. You see this? Do you see this here? This is not just an enum, a regular old enum that's used in memory. This is actually serialized. All of these things are serialized. And if you change them, this is used as a bitmap. And if you change the ordering of this stuff, every privilege descriptor will be completely wrong, right? Because like bitmaps, you know? But we added 2, and they just happened to sort at the end. What? I mean, like, I can't tell if we got super lucky or if we knew it, but like, oh, so scary. You should not be using IOTA for that, or there will be suffering. It is used as a bitmap. It's used as a freaking bitmap. I'm telling you. You see this? It's bad. We should have given them values. I think, look, I just like noticed this and it really scared me because I was about to add one and I was about to like put it in the middle. I was gonna be like, you know, execute permission lives here. And then I realized that it was a bit field and I got really scared, but basically everything is fine. Yay, making an issue. I can see the argument for non-materialized views in this context, but you might as well do it in line. I think that application programmers would probably disagree with you, but I don't know. The other place where this is going to eventually give us is stored procedures, which are different from user-defined functions, but they're no less, I don't know, they're not that dissimilar. And eventually that's going to give us trigger support, right? And yes, triggers are really can be kind of bad in some circumstances, but like realistically, if you involve the optimizer, they're really no worse than just having the optimizer do a couple of things at once. So anyway, one day, maybe one day we'll get there. We're definitely not anywhere near there yet, but okay. So also stored procedures are things that you don't want. Well, you might be right about that, but you also might be wrong about that. I don't know what to say. I don't know what to say. We need to include all of this stuff, right? State. Do we need like offline reason and stuff like that? Do we need like all of this stuff? Defining JSON B traversals and munging seems like a pleasant use case for a UDF. Personally in favor of UDF, strongly against stored procedures for new apps. Entire business logic in stored procedures. I'm sorry. Lithium, I'm so sorry. So basically, I mean, just like before we get into all this, I just want to check one more quick thing to do. Resolve function. Like when we go to do this, is there any way that we could conceivably know at this point what the type arguments are that we want? Because if we did know that, then all of this would be a lot simpler. And I've gone into this project thinking that we didn't know the type arguments, but I just want to like be really sure. I feel like can you know the types of, like in some cases you can, and in some cases you cannot, I think, but I don't remember. If you could know the types, then we wouldn't have a big problem here. Quack. When can you not? Well, I just don't remember the order of operations here. Like, do you? Okay, so here we are in build function. This is where, like, I think this is an example of where the optimizer would be finding a, what does it do? It takes a func expert, right? So the question is, has this been type checked yet or not? I don't remember. I mean, it can't have been, right? Duck types. I did, yeah. I was with you. I was with you. I guess it is typed, huh? But then why is this? Why is the input a typed expr, right? Why is the input a typed expr? Explain that. I feel like maybe we do know the types, potentially. We know the output type, but do we know the types of the arguments? Maybe that's the issue here. So let's like check out what actually happens. We resolve the function first. So at this point, the output type of the function is known, but the arguments are sort of, I think, maybe unknown at this point. Here's the arguments. So for each expr, we wait, but we also cast them to typed expr, which means that they are already type checked, which is truly mysterious. Perhaps there's 2 rounds of this function name resolution. Is that the issue? Is that what's going on here? I don't know. I'm confused. Like, this is where we ultimately do all this crazy type checking stuff, right? That's the whole point. In this huge, complicated function that's just called funcextra.typecheck. Okay, but like the point is, yeah. At this point, I don't actually remember when we do this type checking phase. Is it before opt building or after opt building, or like in the middle of opt building? If it's before opt building, then I guess we're kind of screwed. Like when does this happen? Who knows? I certainly do not. Scope.go, resolve type. Scalar builder. So we resolve type on this expr thing. This like could be theoretically a func expr, right? Yes. So we call type check first. And then I think we're probably going to be in bad trouble then, right? Because what of resolvable func reference or whatever? What of resolvable func reference? Does this thing implement expr? Oh boy, I'm confused. I think that oh, okay. It literally happens at the top of type check, which means that I think that we're in bad trouble because we can't do this. This like is a prerequisite. It's a prerequisite and we don't have, but do we have at this point when do we get the input argument types, right? When do we get the input argument types? Can we only decide the input argument types once we've got the overloads available? Is that a thing? You know why else you're screwed? Function, create function f. Different return types, but that's okay. I don't think that that's problematic. The archetypes are different. If we had the type sub expers, I don't think that this is possible, you guys, because we only type the sub expressions. We only type the sub expressions. It's only possible to type the sub expressions if we know all of the potential overloads. So we're screwed. We can't do it. We can't do it. We can't do it, and that's, I think that's like probably okay. I don't know. And the reason is this like type expectation propagation stuff that's just so deeply confusing, which is that when you call type check on an arbitrary expression, you have to pass in this like expected type business, and or desired, I guess. If you go resolve the parent, then you know all over the no. I mean, we're not screwed with this approach that we were expecting to do next. I just meant to say that if we wanted to do a thing where we like somehow managed to only resolve the specific overload at any given time without having to do it too, I just would like wanted to double check that we really had to do the 2-level lookup thing, and I think we definitely do. I just wanted to like double check before I realized something later that like I would have regretted not knowing in the beginning, basically. Like doing this stuff just makes me deeply sad is basically what I'm saying. So anyway, overloads, we're gonna get rid of this thing. And inside of our parent descriptor, we're gonna have a repeated like, no, let's see. Is it a uint32? What is an ID? It's a uint32. So it's a repeated uint32 overload IDs equal to 12, I guess. Overloads each have their own descriptor in the descriptors table. The descriptor is of type func overload descriptor. Okay. Yep, indeed. So it's going to be nullable false business. I don't think we need that here, right? We only need that if I don't think we need that here because it's a repeated field. Okay, so it's got a name, it's got param names, it's got param types, it's got a return type. It's got an ID. This is gonna match the ID in the descriptors table. Also want to store the signatures for each overload in the parent. Why would we need to store the signatures for each overload in the parent? So that we can avoid having to resolve everything every time, I guess. I guess that's true. Dude, this totally is terrible. It's totally terrible. I really just wish that we could just reserve an ID and not have to store anything in the child. That would be so much better. Yeah. Yeah. Okay, so basically, we store the parameter types of each overload. Don't forget to start winding down chat starting in 25 minutes. That is a good point. I was thinking about that too. I mean, what did we do today? Like we managed to figure out like what we don't know. We managed to figure out maybe a future direction. Separately in the parent so that we can like it just makes me so sad. You're always welcome to quote unquote bomb. I'm just, okay, like thinking quickly ahead. Thinking quickly ahead. Here's the thing that's going to be a problem. Here's the thing that's going to be a problem. It's this. We have this resolve func thing. And this resolve func thing, it gives us something that's a fully realized thing, which is a function definition, right? And if it gives us a fully realized thing, which is a function definition, that implies that either we have to lease everything so that we can fully materialize what's inside of these definitions, right? Or it implies that we have to like plumb name resolution deeper into the stack so that once we have one of these function definitions, we can actually like fully resolve one of these overloads. And that is upsetting because it's nice. Name resolution is nicely contained right now at a single layer. And the idea of injecting it deeper is a little bit upsetting. Decision point is whether we want to eagerly or lazily lease and resolve all of the overloads inside of the function descriptor. Yeah. Yeah, I guess if we eagerly lease everything. Exactly. But this is, okay, so this is what I was saying though earlier, which is that like we don't actually need to store anything in the body of these function descriptors. Oh, well, I guess except for, yeah, it's the dependency stuff. The dependency stuff is important. That lets you store the list of descriptor IDs in the parent. But I think we could store even the dependencies in this parent thing. I think we could store everything in here, and this would only be... Yeah, I don't know. There's things to debate. Okay, so theoretically, let's think about this for a second. Let's look at this resolve func implementation. Maybe this will actually make things a little more obvious. Inside of resolve func, here's what we're gonna do. We're gonna consult our built-in functions, no such function, fall back to user-defined functions, resolve existing object. So basically this thing is going to give us back this fdesk is now going to have a list of names. And then basically what you're saying, which actually is not that bad at all, is that we say for I in range, UDFs get precedence over, no, it just depends on the search path. It depends on the search path, I'm fairly sure. Built-ins all have a schema. So depends on your search path. And this is like broken for that reason. It's a very fair point. We'll have to do something. Yeah. For I in range, we would say for I in range fdesk dot overloads. Basically, we're gonna say, you know, overload desk is equal to resolver dot resolve existing object ctx. Well, it's not gonna be resolve existing object actually. It's gonna be like we need to come up with some other new mechanism that allows us to, or do we have a resolve by ID? We have various lookups by ID. Do these things lease? Based on the common lookup caches, could users flip the collection cache? So basically we'll have another thing here that's gonna be like lookup overload by ID. And this is gonna take a deskpb.id. It's gonna return a funcdesk dot Why aren't you just returning the hydrated parent? I'm just thinking about how to actually do the hydration, right? Or I guess you're saying that you wouldn't want to put the children into the leasing system. I see. So you're saying that maybe what we could do is inside of this deep resolver thing, okay, so inside of this deep resolver thing, if we say get immutable func by name, you're saying that deep inside here. Okay, back to where we started the stream. We have a get object by name. And presumably, I guess I could look at what the type stuff is doing. So inside of the type thing, just assume you can pull it off so that when you resolve the function descriptor, it already has its resolve, release, and start all of its overload descriptors. That makes some sense. Where are we doing this hydration stuff? I guess it's here. Hydrate types in func desk, I see. And so this happens at the end of get func by name. Wait, what the heck? No. Hydrate, no. Sorry. Hydrate types in table desk? I guess it's the same idea. I guess it's the same idea, which is that we make a little function here. We have some function that goes through, and for every user-defined type in a table descriptor, we hydrate it using the wait, what is this from? This is just some other random function. Oh, this is the resolver that we pass in. So we call get type descriptor on this thing. Oh my gosh, this is like kind of complicated, isn't it? Okay, so here's our hydrator. It's that you take an ID, you get mutable type version by ID, you get mutable descriptor by ID of its parent, you get its schema, you get its type name, and presumably one of these things is actually the thing that does the leasing, right? Get mutable type version by ID. The immutable path is more complicated. Oh, great. Okay, cool. Well, that's good. Okay, so here we are in the immutable land. We have some kind of lookup function thing that does the same thing, basically. It doesn't do anything different inside of here. I don't see anything that's different besides just like maybe that it's calling a different function to get one of the types or something. I guess this is different, right? It doesn't. Yeah, so we're calling tc.hydratedtables.get hydrated table descriptor. Okay, this seems actually very important, right? So previously what we do is we literally just like edit the table descriptor to include the hydrated types. But then what we do down here is that we actually call into this other crazy thing, which is, oh no. Oh yeah, I saw this the other day. So there's like this entire complicated cache that somebody wrote, probably you, to do this caching, and presumably we're gonna wanna do something like that that's similar for these function things. This is a moment. This is yeah. This is like pretty complicated. It's pretty complicated. We should generalize this cache. Yes. We should certainly generalize this cache so that it can at least work on any arbitrary descriptor instead of just this cache type thing, which is presumably the value type, right? Oh God. Okay. Let's see. Should we make like a little to-do list here? Let's make a little to-do list. Since we're gonna have to stop thinking about this in a hot second. Should we edit this PR or should we edit the issue? Let's edit the issue. Yeah, okay, so let's go ahead and edit this issue, and we're gonna say, basically, additionally, it turns out that to properly do name resolution for user-defined functions with overloads, there is significant extra complexity. We can't simply store each overload in the namespace table with its type parameters as part of the name, because that would require an uncacheable range scan on every resolution to a given user-defined function. So what we need to do is to implement a 2-level descriptor tree for user-defined functions. The parent contains the name of the UDF, and the children contain the overload types and definition and privileges, dependencies, etc. This is fairly irritating because leasing a user-defined function now requires pulling in all of the children overloads, and leasing them as well. We'd like to follow the pattern that was used for leasing tables that contain user-defined types, which have a similar problem, period. The problem is solved with a special cache of user-defined types that is implemented in the package SQL catalog hydrated, how do I spell things? Hydrated tables package. Cool. Vague to-do list. Parallel to tables, which is easier, but yes, definitely. Big to-do list. Generalize the hydrated tables package to also work with, well, it's not really the hydrated tables package. It's actually just this hydrated cache.go file, I think. Oh wait, that's like the same thing. Also work for function descriptors, I guess. Func descriptors. Thread a func descriptor cache into, where does this thing live? It lives in the table collection. In the table collection to cache the func descriptors. I guess it's not just a func descriptor cache, right? It's actually a func overload descriptor cache. So actually the first thing is like flesh out the func overload descriptor protobuf. Start writing sort of like add logic to create both the parent and child upon create function. Create a func overload descriptor cache into the table collection to cache the func descriptors upon retrieval of the parent function descriptor. I don't know, something like this, right? Details. The details are really what get you, right? I was telling people like, man, this thing is actually not as complicated as we thought. But overloads are actually extremely annoying to get right because of all this stuff. So I'm gonna kind of leave it at this for now. Extremely annoying, you guys, but such is life, right? Such is life. Saying not as complicated as we thought is a sure way to run into complexity. It's like the curse of it's like a curse, right? You know. Wow. I was trying to think of a name for such a curse, and I don't think I have one. The basic idea is you take a descriptive version, go get the least versions for all the reference overloads so you acquire a lease, cache. The cache just sees, have I created it? Yeah. I mean, it makes sense. Makes some sense. The basic idea makes some sense. It's just quite a bit of stuff to go through, huh? What do you guys think of my sick RGB bookshelf lights, by the way? Everything is complicated if you look closely enough. Yeah, exactly. It's like, how does RAM work? So I think, who is tweeting about this stuff? Somebody was tweeting about, like, I think it was maybe IsoStep. Do you guys follow IsoStep on Twitter? She was tweeting something about how she like reached an abstraction limit faster than expected or something like that. She was like talking about, I don't know, some kind of like high level Kafka broker queue architecture for distributed transactions. She was like, what the heck? What does this even, what does it even mean? Korean Doctor Strange, what is up? Nice to see you. It's been quite a while. You've been absent from various media. And I hope it's all well. Happy New Year to you. Well, it's about 5 to 5. So I guess we should prepare for our special guest, huh? Right, Matt? Matt's just chilling in chat. So how are we gonna do this? There's a question. Guess we have to make a Zoom, huh? Go live shortly, then we can coordinate the video. Okay. Zoom? Yeah, DM me that link. We'll see how it works. This should be fun. I think I did this once before. Like at the very beginning of Large Data Bank, I had somebody on like a hangout and we did some pair programming. It didn't work that well. I think it was also because it was like the third stream that I ever did. So I didn't like really have such a good concept of, I don't know, what to do, what to talk about. But now it's been like what, 9 months or something? So more than that, right? Like 12 months, 11 months? I don't know. What I really wanted to do before the stream was to like set up a like a little interview, like a fake interview green screen sort of situation, right? So like it'd be a picture, there'd be like a chair over here, or you could have like a talk show, like a table, and like I would put my head behind the table. And then over here there'd be a little chair, and then Matt's head would be like on the chair. I thought that'd be pretty funny, but I didn't end up doing it because that sort of takes a lot of effort, right? But OBS is so flexible. You can really do anything you want with it. Like, wait a minute. Actually, empty picture of, what do we call, like, who's like one of those people, like Jimmy Kimmel? Wait, not Jimmy Kimmel. Jimmy Kimmel? I don't know. Who are these people? Who watches talk shows? Empty picture of, okay, this is good, right? Like this sort of thing. Okay. So let's take this image. Desk. Okay, let's just YOLO this. This will be super hilarious. Desk interview scene. Okay, wait. You guys can see the magic. Oh no, you probably can't see anything right now, can you? Okay, one sec. Bam. Okay. So we did that. Then we're gonna add the old image source. Oh wait. Right? This is already going to be super good. So we got our face cam. We're going to make it really small. Then we're going to we're going to flip it. Oh no, not like that, right? Definitely not like that. Oh god. Okay. Right? And then we're gonna put Matt right over here. And he's gonna be sitting right here. Matt, welcome to the stream, right? What do you guys think? I feel like it's not really gonna work out, to be honest, because the truth is that I don't think that Zoom is gonna let me use both the camera for this thing and Zoom at the same time. Let's see. Okay, so Matt has sent me a link. So let's see. We're gonna open our Zoom here. This could be a total disaster. Who knows? Who knows? Failed to connect to the camera due to a conflict with the running of a... Okay, wait. You guys, no. I have a good idea. I have a really good idea. It's called the virtual camera of OBS. Let's zoom. Matt! Am I too loud? Can viewers hear Matt? Right. Oh, Matt does not exist for us. Okay, hold on. I think I need to... PC output is not muted. Hold on a second. Let's just figure this out real quick. Definitely should have prepared. Okay. Microphone, same as system. What I need to do is change my output sound, and then we're going to be killing it here. The output sound is actually going to be Soundflower plus Yeti. Okay, Matt, say something.
Yo, what's up, Twitch chat?
Yes. Okay, Twitch chat can hear you now.
Awesome.
Now, if you will just bear with me real quick, I just want to make sure that I can put your face on the couch, just because we're so close. We're so close.
So on my stream, we're gonna have the couch with both the faces, and like the delay and stuff. But yeah, we'll make it work. That's pretty funny.
Oh, that's a good point.
Oh, I don't care. I mean, whatever you want to do. I think the reality is here is that, like, people are gonna watch whatever, and like I'm just gonna pay attention to both chats. But this is gonna be pretty funny. I'm excited.
I'm also excited. Display capture. Okay. So we got this going on. Then we're gonna make you really small.
This is so silly.
And then we're gonna kind of cut you off over here just like that. And then we're just gonna make sure never to move you on my main monitor.
See, my problem is I'm always afraid of like messing with my OBS settings on stream because I feel like I'm never gonna get them back.